Hello, abstract algebra students. We will now finish the proof that matrix multiplication is associative on M2R. So we had already reasoned the matrix A times B times C with A times B in parenthesis into a matrix. Now let's calculate the other side and reason it into the same thing. So now we are going to, independently of the work that we did before, take the matrix A times, open parenthesis, B times C. And we will try to get the same thing. So here the matrix A is outside of parenthesis. We'll put in the ABCD for matrix A. Now we will do times. And we'll put the matrices B and C inside the parenthesis. E, F, G, H times I, J, K, L. Again, this is just substitution of the matrices A, B, and C that we assumed without losing generality. Now, we will work this expression out with the goal being to have it end up the same as that. But let's see if we can do that. So remember, we have to do what's inside the parenthesis first. Since the matrix ABCD is not inside the parenthesis, I'm just going to let that alone for now and copy it along. And I'm going to work out the product that is inside the parenthesis. So when I do that, I get EI plus FK. I get GI plus HK. I get EJ plus FL. I get GK GJ plus HL by definition of matrix multiplication. Now, let's work this out one step further. Let's do the next product. So I get A times the quantity EI plus FK plus B times the quantity GI plus HK. And then down here, I get C times the quantity EI plus FK plus D times the quantity GI plus HK. Now in the second column, I get A times the quantity EJ plus FL plus B times the quantity GJ plus HL. And then I get C times the quantity EJ plus FL plus D times the quantity GJ plus HL. Now let's distribute these. So in the top left entry, AEI plus AFK plus BGI plus BHK. In the bottom left entry, CEI plus CFK plus DGI plus BHK. In the top right entry, AEJ plus AFL plus BGJ plus BHL. In the bottom right entry, CEJ plus CFL plus BGJ plus DHL by the distributive law. Now, if you look at each of the four entries, you will see that the terms in each of the entries are already alphabetized. So we can check AEI, AFK, BGI, BHK. AEI, AFK, BGI, BHK. They match. AEJ, AFL, BGJ, BHL. AEJ, AFL, BGJ, BHL. They match. CEI, CFK, DGI, DHK. CEI, CFK, DGI, DHK. They match. CEJ, CFL, DGJ, DHL. CEJ, CFL, DGJ, DHL, they match. So therefore, now that all four pairs of corresponding entries match, we can say, therefore, by definition of matrix equality, we may conclude that A, the matrix in parenthesis, A times B, times the matrix C equals A times the matrix in parenthesis B times C. And that ends the proof. Okay, I will zoom this down so you can see the whole claim and proof now. Okay, so the way that we proved associative was we let arbitrary A, B, and C be given, and we showed this equation by reasoning both sides into the same thing. Now, with matrices, we have matrix multiplication is an operation that is associative, but not commutative. That's just the reverse of what we saw last time with double addition. That operation was commutative, but not associative. So now you know neither of commutative nor associative imply the other. These are two different properties that can either be both be true or both be false, or one be true and one be false. Do not get those properties confused in your mathematical career. More to follow.